Good morning, everyone. I have the dubious distinction of coming right after the keynote that makes everybody cry. So I have to say that you may cry, but it's for a different reason because of your JavaScript coding. But we're going to jump in today and discuss linting rules for JavaScript. And of course, this is kind of a deeper level talk. Because I'm going to show code and I'm going to expect that you can follow along quickly. There's going to be quite a bit of code. I'm not actually doing any live coding, but I'm going to show you code and show you things from my experience. So where we're going to start with is this linting tool that I wrote to basically give a set of opinions about code. So we're going to actually spend our time today on the command line using this linting tool. And if you'll notice closely, this linting tool I wrote way back in 1995 when JavaScript first came out. That's obviously a joke because that wasn't true. But I did write that, this linter to try to help us understand JavaScript because that's what I spend my time focusing on. So just real briefly, I can give you some information about myself if you don't know who I am. Kyle Simpson, that you can't read, but I'm Kyle Simpson. Getify online. If you're into the online stalking thing, you can check out getify.me, and it has links to everything that you need to know about me. And I do appreciate feedback, both positive and negative. I get people that tell me, you're full of crap, and I love getting that sort of feedback as well. So do feel free to reach out and give feedback. Definitely also make sure to do the voting so that we, as speakers, can get better at what we do. I'm an open web evangelist. I'm based in Austin, Texas, over in the States, but I basically visit there these days because I spend my time on the road. I speak about JavaScript and I teach JavaScript. So as a tiny little plug, if your company is interested in having someone come and teach about JavaScript, please let me know because I'd love to do that. All right, so kind of a setup here that we need to understand about why this talk is this way. I think our industry has benefited tremendously from books like JavaScript, The Good Parts, but it's also hampered us as an industry because I believe it's taught us to sort of run away from the difficult parts, the tough parts. So the books that I speak about and the books that I write and the things that I'm speaking about today, in fact, all the teaching that I do, it's really designed to take the alternate approach to things, which instead of saying, let's relegate ourselves to a small subset of the language, it's JavaScript, all the parts. So I'm sort of the anti the good parts, but that doesn't mean the bad parts. It just means that we're going to go after all of the parts of JavaScript. We're going to jump right in just a moment talking about types and then about coercion. And those are the sorts of topics that most people say, oh, I don't need to learn, I should avoid because we've been told that they're just bad. And I'm going to take the opposite approach to that. So since I mentioned the books, I should just go ahead and do a quick plug of these books. This is the You Don't Know JS book series, and I have some of these. I have 3 copies, so it's not a lot, but the first 3 people that want to come up and grab a copy, they're also for sale out there. I think they're giving 20% off, but you can read the books for free up on youdon'tknowjs.com. So it's a series of books. I've written 3. I'm working on the 4th title right now. There'll be a total of 5, and I also have free stickers if you're interested. So enough of that self-promotion junk. Let's jump in. The stuff that I'm going to talk about today, how many of you, by the way, how many of you use a linter on your own coding? So JS lint, JS hint, things like that. Okay, good. Those of you that are not, I highly encourage you to do so. But we need to make sure that we understand something about linters that I think is commonly confused. Many people think that linters are about checking program correctness, and that is not true whatsoever. Your program correctness is validated by your unit tests and also by running your programs in production. That's how you know if your program is correctly doing what it's supposed to do. It's also not checking validity. Your program validity is checked by your compiler, by parsing the code and checking to make sure that the grammar rules are correct, that you're not doing illegal things. Those are all things that existing other tools do. So then what is the linter for if it's not for correctness or validity? The linter is a set of opinions. You probably have seen JS lint, that statement about that the linter will hurt your feelings. So today's talk is a linter. And I might hurt your feelings, quote unquote, by suggesting to you things that I think you're doing that I think are dumb in code, but they all come from the same mistakes that I've made. So I'm really speaking mostly to my past self as well as to the rest of us. So, but in the same way that when we use linters that are a set of opinions about how our code should be formatted and styled and the idioms that we should use, in the same way that we use linters to do that, I want you to take this that I say to you today with a grain of salt. Understanding that these are just my opinions, and you can choose to use those. Hopefully this piques your interest and it gets you to ask difficult questions about your code, discuss it with your team, but you're free to pick and choose. So when we call it a rule, it's just a set of opinions. Okay, so without any further ado, let's go ahead and jump in. The first thing that we're going to jump into is a discussion about types. I'm sure many of you have probably heard the statement before that JavaScript has no types because it's a dynamic language. And that's the first myth that I'd like to bust for you. To suggest that JavaScript has no types is to not understand the mechanism whatsoever. Now, the word type, of course, is very controversial depending on which language background you come from. If you come from a static typing background, something like Haskell or something like that, you're going to vehemently disagree with me using the word type. And you're going to suggest to me that I'm completely abusing that word and using it incorrectly. So what I will fall back on is that I didn't make up the word type. I came along a lot later after, and it's actually the people that wrote the specification. This is a snippet from the specification of JavaScript that uses the word types to describe, and I'll give you a loose working definition for what we talk about here, a set of intrinsic behavior that is associated with a particular value. For example, the number 42. We know, beyond it being the meaning of life, we know that the number 42 being a numeric type is something we can do math with. We can add and subtract and multiply and divide those numbers. The string 42, quote 42, is a different type of value. Of course, it might be outputted the same, but we use strings differently. We concatenate them, we split them, we upper and lowercase them. We do things differently with these different types. And in fact, the specification, as you see right here, it says, an ECMAScript language type corresponds to the values that are directly manipulated by the programmer. I think that's really important to illustrate. My working definition for types is that it's based on the aesthetics or the ergonomics of what we do in our code. We reason about the number 42 value differently than we reason about the string 42. So these are types. So let's go back to start linting some code. I'm going to check a file that I've got called types.js, and we're going to see what the linter has to say about some of these types. All right, so we see right off the bat type of operator and type of null at the very top. Everybody's favorite bug in JavaScript, the type of null returns object. It's just plain old simple. It's a bug that ought to have returned the string null. But let's look at some of the other ones. They're more well-behaving. Type of undefined returns undefined. Type of true returns Boolean, string, number, object. And then down at the bottom you see function. Now, you would be forgiven, as I was for many, many years, if you thought that function was an actual type. In fact, if we go back to the specification, functions aren't really a type. They're really sort of like a subtype of the object type. And we know that all functions are objects. I'm sure you've heard that before. But as a subtype of objects, it's probably more appropriate to think about functions as callable objects. They are objects that have this special capability that they can be called. But again, from the ergonomics of the language, we see that type of function returns the string function. So we reason about functions very differently than we do about general objects. So I think it's appropriate, at least from the ergonomics, to think of that as a type, or rather perhaps as a subtype. Okay, so the type of operator returns one of these 6 strings. This is ES5 and below. There's a new one that's being added as of ES6, but we won't dive in that today. So one of 6 possible strings can be returned, and they correspond directly with the types that the spec calls out. That's my case for why these are types. So if you're going to argue and say, well, it ought to have been called tags or something like that, take it up with the spec authors. As far as I'm concerned, the way I write my code, I reason about the number 42 and the string 42 differently. Okay, so let's see if the linter had anything to tell us when it was checking these things. It gave us a couple of warnings. For sure, the warning about type of null being buggy. And also it gives us a warning that even though the type of function returns that object subtype, we should be careful about. So be careful about these type nuances. Another thing to point out, by the way, if it wasn't obvious to you, that in JavaScript when we have dynamic typing or non-type enforcement in our language, we have types but they're not enforced. What that really means is that in JavaScript variables do not have types. Values have types. The value 42 has an intrinsic behavior associated with it, that it's mathematical, that it's numeric, so the value 42 has the type of number. But the variable that's currently holding 42, it has no type whatsoever. It's just a general container that can hold any value of any type. So it's important to keep that in mind because that's different from other languages with type enforcement where it's not the value that we reason about the type, but it's the container. We declare a container that can hold integers. We declare a container that can hold arrays to strings and so forth, array pointers to strings. Okay, so now that we understand that there really are types, the next thing that we're going to want to deal with, let me pull up the man page for everybody's favorite thing to hate, which is coercion. The double equals operator, many people have heard about in JavaScript, and many people have heard that it's evil, that we shouldn't be using the double equals. But I would push back and I'd say that double equals and coercion can actually be quite helpful, and I would caution you to beware of all of that negative hype that you've heard. In fact, we're going to push on some of that and see that some of those assumptions have really just been FUD. So let's pull up the man page for the double equals. How many of you have heard this before, that double equals checks the value and triple equals checks the value in type? Unfortunately, that's not true. Actually, what happens is that double equals allows coercion and triple equals disallows coercion. Now, why does that matter? Am I just parsing nuance in academic speak? Actually, it does really matter. It matters from a correctness perspective, but it also matters from the way that we reason about these things. If you look at the first set of descriptions, which one of the two of those appears to do more work? And clearly, the triple equals appears to do more work because it's checking both the value and the type. But if we look at how it actually works, if we look at what the spec says about how it works, double equals allows coercion, and triple equals disallows coercion. Therefore, double equals appears to be doing more work. And in fact, this bears out. If you were to do performance tests with values of different types and you were to compare using double equals versus triple equals, the coercion rules that go through do actually take a little bit of time. Not a lot. We're talking about a couple of microseconds difference. So you're not going to see any differences whatsoever. If you've heard people say, always use triple equals because it's faster, that's just FUD. Because nobody here is going to be writing programs where you're going to be doing tens of millions of comparisons all right together in one particular thing to even come close to noticing 4 or 5 microseconds difference between the two. So it really reframes things. Now, I'm going to have to question a little bit of authority here because many of you are going to say, but I've read the good parts. Doug Crockford, he's a smart guy, he knows what he's talking about, and he says that we should always avoid the double equals. Well, actually, that's not entirely true. Because if you go to his book, which I will use a quote from, if you go and look at his book, he says, blah, 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 when comparing any of these following values, always use the triple equals, right? But it's that part that I've highlighted there. If you want the type coercion, then use the short form. Right there in the Bible for JavaScript that everybody has taken as their religion for how to understand what JavaScript does, Doug Crockford himself endorses the idea that if you want type coercion, then the double equals form of that operator, the shortened form of those operators, is the appropriate mechanism to use. Which actually reframes this debate. It's not about whether Doug Crockford likes it or not. It's actually about, do you want type coercion or not? And many of you are going to say, absolutely I don't, because it seems like black magic. And I'm going to try to prove to you in just a moment that it's not. But I really want to reframe this debate. It's not that it's evil or bad or buggy or magical or any of those sorts of things. It is simply a question of choosing as a responsible developer. Is this a mechanism you want to use? Is it a tool you want to use or not? So let's pull up, or let's lint ourselves another file. I'm going to look at a set of coercions. And what I've tried to do in this file is come up with the worst of the worst. I could give you literally an infinite list of cases where coercion works exactly the way we would expect. There's lots and lots of places where coercion is totally sensible, but let me give you an example of a list of sort of the worst possible offenders here. I picked out 24 sort of corner cases, the worst possible offenders that we could come up with in coercion, these falsy values that tend to create some weirdness. And you'll notice that out of the 24 of them, I've marked 7 of them as uh-ohs. This is oops, this is some gotchas. But out of 24, there are 7 of them that definitely bear some further examination, and then there are 17 of them which are completely sane and reasonable. And that probably doesn't fit with what you've heard, which is that most people suggest that coercion is all evil or it's mostly evil. And in fact, the comparison visually here is that most of coercion is actually quite sensible and reasonable. And there's a few small cases that we should avoid. And we'll look at what those cases are. I'm going to try to give you some practical takeaways to avoid those 7 O's. And it's not going to be as difficult as you think. But if you were to try to make this list, it's an infinite list of really good coercion stuff that's useful if you'd like to use it in your program, and 7 gotchas that if you could come up with a simple set of rules like the 2 that I'm about to share with you, then you could avoid those 7 pitfalls and use this mechanism to make better, shorter, cleaner, more concise code. So let's go back and see what the linter might have had to say about this. You notice that it calls out those 7. It gives us some warnings. So for example, warning, quote 0 equal false uses an unsafe equals coercion. So it's telling us these things are unsafe. You shouldn't do that. So 7 warnings, 17 out of the 24 coercion tests were perfectly fine, and we should avoid the few unsafe ones. Now, if you have trouble with some of these corner cases and the rules, in fact, if the rules give you issues. I have lots of bugs in my code, but types are almost never the thing that causes bugs in my code. But if you do struggle with that, there are tools that can actually help. So let me give you just one tool that I like. It's called restrict mode. And if you look at restrictmode.org, you can see that they have a build tool. This does not transform your code for production, but it's a development side build tool that will transform your code. It will go through all the places that you're doing these quote-unquote unsafe coercions, and it will put checks around them. And then you can run that code with real input. And it will spit out warnings if you're doing stupid stuff, like, for instance, comparing strings to arrays. That's an unsafe comparison. But if you're doing safe things like string and number, which in almost all cases are totally rational and sane, if you're doing those, it doesn't spit out any warnings. So if you're struggling with this and you're saying it's just too difficult for me to reason about just 6 tiny little types, then there are tools that can help you with that. It's not well, I have to avoid all types entirely and all this nonsense about things. In fact, most of that noise that's made in our industry where people say coercion is bad and it's evil and we shouldn't do it, if you go and look at the code of the people that are saying that, they use coercion all over the place. Yes, including Doug Crockford. You can open up his code and he uses coercions, both implicit and explicit, all over the place because it's a reality that that's what's important. So that's really more one of those cases where he's saying, do as I say, not as I do, which is ridiculous, right? See, there's something deeper here. We need to be more responsible with our code. So, restrictmode.org is a nice, useful tool, and there are other tools out there. I think Facebook is coming out with a tool called Flow that seems to be doing something very similar. So there are tools that can be made, and you can make your own tools to do your own checking. So let's actually go back to checking some more code, because I mentioned that there are those 7 bad cases. So let's actually dig specifically into those bad cases for just a moment. Remember these 7 bad cases. These are the oops. These are the uh-ohs. Okay, so I've partitioned them off, the 4 on the top and the 3 on the bottom. The first rule that I want to give you as a takeaway is that you should never, ever, under any circumstances with 0 exceptions, ever make a comparison with double equals false or double equals true. If you're doing that, you are doing it wrong, plain and simple, end of story. Double equals true and double equals false should always be avoided. So what we see here is the first 4 of our 7 are using a double equals false comparison. Now, I could dig into the real reasons why that is, but generally speaking, the reason why those should be avoided is because it tricks our developer brains, that the way that it explicitly has a Boolean on one side, it tricks our developer brains into thinking that it should take the other side, the thing that's not Boolean, and make it Boolean. But that's not what the algorithm says. You can open up the spec, and it's a very simple 10 or 15 lines in the spec that says exactly what to do. It's not magic or random or anything like that. But the spec does not say, if Booleans on one side make the other thing truthy or falsy. The operator tries to trick us when we use it like that into thinking that's what should happen, but that's when we get these weird things. Like, for instance, that false is equal to empty string. We would think that it should take that and make it equal to a false, and so it's just sort of a happy accident that this ends up being true, but that's not really what's happening at all. In fact, most of these coercions, depending on the way you go through the steps, most of them end up converting to numbers and doing comparison of numbers. So, avoid double equals true and avoid double equals false, and we've immediately taken that list of 7 bad offenders and pared it down to 3, the 3 that I showed there on the bottom. And I won't belabor any more specifically, if you dig into these things, there's actually reasons why lines 7 and 8, you almost never would actually compare anything directly to an empty array. That's kind of ridiculous when you actually try to examine the way that that would happen in a real code, because we know arrays are held by reference, so you would already have some other variable on some other side that had to have some reference in it. So it's not common that these sorts of things happen. And that's really the theme that I'm trying to get across here, is that you've been told and you've been believing that coercion is a real pitfall, that it's going to just break every single program out there. And in reality, there's not a lot of problems that actually crop up. If you want to read more about that, by the way, this third title of the book series, Types in Grammar, it has a whole like nearly 70-page chapter on coercions, and I deal with specifically all of these cases. So basically, if you don't follow the rules, you get what you deserve. Don't be dumb. The rules are, rule number 1, never use double equals true or double equals false. And rule number 2, if the values can be empty string, 0, or array, you should be careful. You should probably avoid using the double equals. So reason about your code and decide, is it possible for the values in my comparisons to ever be empty string, 0, or empty array? And if so, just out of an abundance of caution, avoid it. But in all other cases besides these two, this is literally the only rules, and I believe you can use all the rest of coercion to make your code simpler and more straightforward. Instead of having these double equals true and double equals undefined and things like that, I think it's much better to use the sort of terse form. I have this kind of theory about coding. I don't know if it applies to anyone else, but I have this theory of coding that the more things that I write, the more chances there are for me to screw something up. So I prefer to write less code when it can be terse and still be correct. Another example where coercion, for example, why coercion can be useful, is null and undefined. If we open up the spec, then the spec says that null and undefined coerce to each other and to no other values in the language, which is actually very useful. We can treat them as indistinguishable. So I have this A and B, and we notice that A and B are equal to each other, but neither A nor B is equal to any of those other troublesome falsy values, because they coerce to each other and to no other values. So your choice is line 4, which I think is much more straightforward, or things like line 15, where you're having to do things very explicitly with the triple equals. And when people tell you, well, it's better to be more explicit, they always gloss over the fact that you actually have to do 2 comparisons now rather than 1. So even if it was tiny, even if triple equals was a tiny couple of microseconds faster when you only do it once, when you do it twice, it ends up actually being slower. So the reality is that there's a lot of FUD that I think we should let go of. We should start using coercion to our benefit in our code. So let me boil this down for you, because everybody likes tweetable pro tips. Use coercion where it's safe and convenient, and don't use coercion where it's unsafe. Plain and simple. Be a responsible developer. Don't just listen to the hype that somebody said along the way, or you had some bug and it was because you ran across some corner case. That's not a sufficient reason for throwing out an entire important part of our language. Rather than running away from the things that are a little bit difficult, maybe we ought to run towards those things and learn them. And I've just given you 2 simple rules which should help with that. Okay, the next thing that we're going to talk about, I'm going to pull up the man page for anonymous. Not the hacker group. Anonymous functions are always a bad idea. I'm going to give you 3 simple reasons why I think you should never, ever, under any circumstances, with 0 exceptions, use anonymous function expressions in your code. They yield confusing stack traces, and they make your code harder to read. I think you should avoid them. So let's pull up. I will check anonfuncs.js. Okay. How many of you recognize code like this? Anybody ever written code where you've got click handlers and then AJAX calls and timeouts inside of those things, and we nest these things together? All right, so I have 3 functions here. You'll notice that on lines 1, on lines 3, and on lines 5, I have these anonymous functions. Now, at the moment, I'm not actually talking about whether it's inline or not. I'm simply talking about whether it is an anonymous function, because it has, for example, function open close parenthesis. It has no name there. This is, of course, the most common idiom that you see, and it's encouraged. This sort of anonymous lambda style is encouraged by people that do coding in all these other languages, in all these frameworks, things like jQuery and so forth. So it's incredibly easy and simple to sort of write that kind of code. But I would suggest to you that you're making bad code decisions by using anonymous functions. You should always put a name there. Let's see if the linter had anything to say. Yeah, all 3 of those, it said the function ought to have a name. Anonymous functions make your code sad. What is the alternative then? If I were to fix it in anonfuncs2, the alternative is to simply insert names. So I now have names like handler, request, and response. None of the rest of my code has changed, but instead of doing ridiculous things like using arguments.callee or other weird ways, of doing self-reference, you'll notice that I have nice, convenient lexical variable names like handler and request to refer to these functions. So I promised you 3 reasons why. The first one is that when you name a function expression, it gives you a simple self-reference inside of that function. No, it's not the this keyword. We're going to get to the this confusion here in just a moment, but the this keyword is not how you self-reference. If you give a function a name, a function expression a name, then you get a self-reference. So it makes it easier for recursion, for event unbinding, things like that. Always give it a name. And by the way, give it a good name. Don't use foobar. Give it a reasonable, useful name like I've done here with handler, request, and response. So that's the first reason. The second reason why it's better, and I think this alone stands on its own as a sufficient reason, is that how many of you have ever had stack traces where it said anonymous function, 1,000 times? It's ridiculous and difficult to debug. Guess what? If you put a name on your function expressions, it uses the name in your stack traces. So it makes your code easier to debug, especially if you use a reasonable name. And especially it's true if you've got this code like it's all minified onto one line and it's like line 1, character 32,712. Nobody knows what that is, but if you've given it a useful and reasonable name, you have a better chance of understanding and debugging your code. And the third and final reason is that it actually I think it's stylistically, it makes code more readable. I do not have to look at the surrounding context of the function header for the word for the function response. There on line 3 as we show. I don't have to look at the surrounding code to understand what that function's doing. The name that I give it is sort of self-documenting. If I had the anonymous functions like I did in the previous code snippet, in the anonymous functions here, I actually have to look at the context. I have to go and look for what is it doing. And that's not useful to anyone. That's going to create more confusion for your code. So simply giving them names. Those are the three reasons. Self-reference, better debuggable, and better code maintainability. Okay, so there are other problems, and this one is saying that in this particular case, there's not really any value in using the inline nested functions. Now, this is where I am actually suggesting that perhaps you shouldn't even use function expressions. Maybe you should pull things out as function declarations, as I've done here, because with function declarations, actually things get an awful lot more readable. Instead of nesting things together the way people have always told you, I didn't change any of the functionality of my code, but I used function declarations with those same names, and now things are a lot more reasonable because I can look just at the handler function and understand that after a timeout, it calls the request. And then I can look just at the request function and understand that after an AJAX comes back, it calls just the response. And then I can look at response and see what other functions it calls, and I can reason about these things independently, which makes code much more readable and maintainable. So in many cases, you've been told, use these inline functions because you need to do closures or things like that. All that's nonsense. There's many cases where function declarations pulled out can actually make more readable code. Okay, moving on. Oh, there's a problem with that code. You'll notice that I subtly introduced an IFI, an anonymous IFI here, right up here at the top. Anonymous IFIs shouldn't exist either. No anonymous functions, period, no exceptions. So we should simply insert a name, like for instance saying, IIFE, or give it some other name that represents what that file is doing or something like that. Give it a useful name, but don't use anonymous functions. Okay, so that's it for my talk, for my discussion on that. Let's jump to a very related topic, which is scope. So let's pull up the man page for scope. And I want to go quickly through this, but I just want to point out that the var keyword can sometimes confuse and even abuse your function scope. And there's this thing called block scoping, which is coming new to the language. We're going to talk about why that's useful, because block scoping can actually help. I'm not saying to replace all of your code with that, but it is very useful to do block scoping where it's possible. So let's look at a particularly ugly piece of code. I just made this code up. But in this ugly piece of code, what you notice is that we have these var keywords strewn all the way throughout this code. And how many of you have ever heard that old adage that says you should manually hoist all your vars to the top of your functions? Anybody have just one big long var? I've done that plenty of times. So unfortunately, that doesn't actually end up creating a panacea. In this case, we have these vars that are nested inside of these inline blocks, and it's confusing whether or not they're intended to be used only for the block or whether we're implicitly relying upon hoisting, or we don't even know. So when you look at somebody's code that's doing that, that's putting vars inside of blocks like that, you don't know if they intended it that way or if they're just being an idiot. And that's kind of the problem. So one of the reasons why manually hoisting to the top is that there's no confusion. So vars strewn about the code can create issues. So it's very common for people to then do manual hoisting, like we'll see here in scope 2. In scope 2.js, I've manually hoisted all my variables to the top. So I have no more vars strewn throughout. Now, if you have a short function, not such a big deal, but if you have long functions, as many people tend to do, then you start to run into very similar problems where now the code is confusing, because if I'm way down deep here and I'm like, wait, where is I coming from and G and that sort of thing? Was it a parameter? Was it a local variable? You have to scroll all the way top to find a function with a variable declaration, and that can become difficult. And I think the linter actually has something to say about that. The linter says all the vars at the top can also be confusing. The point is, stringing your vars across the code is confusing, and putting them all at the top is confusing, so there has to be somewhere in the middle, and it is that block scoping that is in the middle. So let's take a look at the man page for block scoping. Block scope declares variables as close to their intended usage as possible and scopes them only to an enclosing block, not the whole function. If you have experience from other languages, you already understand that it's the principle of least privilege, or the principle of least exposure. Make the variables only used where we need them. For example, for loops. When you do for var I equals, you're declaring stylistically that the I is only supposed to be used for the for loop. So you're doing exactly that. You're, in a sense, stylistically block scoping your I, but it's not enforced yet in JavaScript, which is actually why it's very cool that JavaScript is adding direct support as of ES6 for block scoping. So if we go into scope3.js, you'll notice here that I'm doing something interesting. I'm actually doing manual blocks. I'm creating explicit blocks like I do here on line 12. I have what is called the let statement form of this keyword, the new let keyword that's coming in ES6. And I'm creating a manual block for the scoping of G. And I'm saying only in this block does G exist, and don't use it outside. Now, JavaScript's actually going to enforce that. If you try to use G outside of that block, you're actually going to get an error back, which is a good thing for us. But you'll also notice that I can use let I instead of my for headers, and I can even do let declarations like let f equals c and so forth. So I have both the let block form, which I'm a bigger fan of, and I'll explain that more in a moment, or this sort of implicit let declaration syntax. In either case, these variables end up belonging only to the blocks that they exist for and nowhere else. So am I saying only do lets? There are people on the TC39 committee that are on record as saying let is the new var. Just do a global find and replace of all your vars and make them to lets. I think that's absolutely patently absurd and ridiculous. I plan to use both. So in this case, in my stupid example, I have some vars because these are variables that I'm going to use across the entire function. And then I have some lets in places where I have localized variables that are only going to be used in small places. And to me, that's useful to have both keywords in play because it's a stylistic signal to me. When I see var, that means used everywhere. And when I see let, it means used only in this block. And I've chosen to apply that style to my code, and it's made my code a lot easier to understand for me. So there is this whole thing with the let blocks that we want to address. Let's just go back here and see. The let keyword isn't valid until ES6, so that's kind of a bummer, but there are ways to get around that. There are tools. But notice this third warning that it gives us. It says, it's confusing that let is implicitly hijacking a block scope. And I agree with the linter here, because I wrote the linter. That it is confusing. It's an implicit mechanism. I have an if statement that becomes also a block of scope if there's a declaration inside of it, which means you don't just look for functions now. Now you have to start looking for every matching curly brace and then scanning the entire contents of that curly brace pair to see if there are any let strewn anywhere throughout, because you can put them wherever you want. And there's hazards with hoisting and all sorts of things. So it's an implicit mechanism, and I'm not a fan of that. But the syntax of let blocks, unfortunately, we see here the next one, it's actually flat out wrong because that's not even valid JavaScript, which sucks. ES6 decided to reject the let block syntax, the one I think that is superior, and they chose to keep that inferior implicit mechanism. So it sucks that we would prefer to do these explicit blocks, but that particular form, even though I didn't make it up, it's something that Firefox had for a long time, but they've rejected it, at least for now, out of JavaScript, which means that we can use tools. So I wrote a tool called Letter, and this tool is designed to solve that problem. Okay? And what Letter does is it transforms non-standard let blocks into standard JavaScript block scoping. So you can use this as a pre-processing tool, just like you use other build tools and things like that. It's just another step in the process. And you can start writing with explicit block scoping and just simply transform your code. So very quickly, what does it do? If we look at scope4.js, it's going to illustrate for us what the Letter tool does by default. By default, it's going to say, well, you want to transpile all the way back to ES3, so you can use it in all today's browsers. So we can start out with a block like this, and when you use letter, it creates this ugly crap, which actually takes advantage of the fact that catch blocks are block scope. That's a little known fact. Nobody wants that kind of stuff, but those are the hacks that we have to sometimes deal with in tools. And in fact, many other tools use this. There are other hacky tricks, like there are things where you can stick ifs in there, or you can do this thing called hygienic variable renaming. There's various other hacks. This just happens to be the one that letter uses, but it means it works. It actually enforces it. If we try to reference A outside of the block, it was in fact truly and correctly block scoped only to the block. But it turns out that we've got a much better way of doing it, because when we don't want that ugly thing, when we're already going to be using tools to bridge into ES6, we can even just switch on the ES6 flag in this letter tool. And it will take that same block, and instead of writing that crappy, ugly stuff, it will write something that is valid ES6. You notice I just have an empty, naked curly brace pair there. That's very idiomatic in other languages, but it's very uncommon for people to do that in JavaScript, but it's still totally useful. So we can create these explicit blocks exactly like I'm doing here on our own, or we can use the syntax that I was suggesting that Firefox has had for a while, and then use a tool. But I still think this is a much better form of block scoping. Create your explicit naked blocks for this, and then use the letter keyword, the let keyword at the top of those. And so you'll notice the transformation between line 1 and 2 and line 10 and 11, it's a very subtle transformation. They still are going to behave exactly the same. I think line 1 and 2 is slightly better, and that's why the tool might be useful to you. But in either case, you should use explicit block scoping, in my opinion, rather than implicit. Okay, one last thing on scoping is loops. Loops actually benefit hugely from block scoping. Loops and block scoping solve pesky issues with closures. And when I show you this code, this might loop familiar to you if you've ever written loops with functions inside of them and had problems like for your checkboxes or your things. I'm going to show it with timeouts here. But in going back to that previous code sample, here's I've pulled out a version or a snippet of it. And you'll notice here that I have this set timeout that's referencing an I. In the previous code, when I was using just regular vars, this code would break because it's not closing over a different I for each iteration. But it turns out with the let keyword, this let I, the I doesn't just belong to the for loop, it's actually specified to belong to each iteration. Under the covers, JavaScript's creating a whole new I for every single iteration, which means you automatically close over a different I for each iteration, and closures just start magically working. With all that crappy iffy hacks that we've all done for years, let scoping with for loops is actually a huge win. It solves a lot of those issues with closure. So I'm a big fan of block scoping. I think you should use it in your code. I think you should start using it now. Okay, let's move on. The next thing we're going to talk about, the this keyword. How many of you have ever had struggles with the this keyword? It's one of the most commonly misunderstood in all. And I'm showing some tweets here from people that have done crazy things like this.method.call this, which is absolute insanity. I love this one. New this.constructor passing in this. What on earth are these people thinking? The plain and simple fact is that nobody has any idea what they're doing with the this keyword. I hear it all over the world, all the time. People suggest that, that this keyword is doing something. Almost every post on Stack Overflow, it's all suggesting it's total crap. It's totally not how it actually works. So I actually want to talk to you very quickly about 4 simple rules of how it actually does work. It's not nearly as confusing as you think. There are 4 rules, and I'll very quickly go through them. The first rule is if you put a new keyword in front of a function call, like I'm doing here on line 13, you'll see that new something, I put the new keyword in front of a function call. The new keyword is going to create a new this binding and use that this binding for the function call. Don't be confused that the new keyword has anything at all to do with instantiating classes or any of that nonsense. There is no such thing as classes in JavaScript. I don't care what you've been told or what you've read. It's all nonsense. There aren't classes, and these aren't constructors. This is putting the new keyword in front of a function to create an object and bind it to the this keyword. So that's the first rule. Check if the call site. Go look for the function. We wanted to understand inside of the something function here, what is this keyword going to point to? The first thing is, does it have a new keyword in front of it? That's your first rule. Okay? Let's look at the next rule. I'll look up this2.js, and in the next rule, we'll see very straightforwardly that the second rule, rule number 2, is if you put a .call or .apply at the call site, then you're manually saying, I want to use obj1 as the this binding for that function call. So the first rule, does it have a new keyword in front of it? If not, go to the second rule. Does it have a .call or apply? And if so, that's going to be the object to use. Very straightforward. That's just 2 of our 4 rules already. If you want to write these rules down on a Post-it note, stick it on your monitor next to the Post-it note with your passwords, and you'll never be confused again. Nobody gets that joke. It's always too early in the morning. You'll never be confused about the this keyword ever again. Okay, let's look at the third rule, this 3.js. Oops. This 3.js. We pull this up and it says, okay, here's my function something. It's still got the same this. Rule 3, does the call site have an implicit context object at the call site? You've probably seen that. That's probably one of the most common ways that people invoke methods, as they're called in JavaScript, functions that exist as references on objects. obj1.something says, if none of the other two rules have applied, which they don't here, then the third rule says, use the implicit context object at the call site. In other words, use obj1 as the this binding. And in fact, that is perhaps, even though it's the third of the rules, is perhaps the most commonly used rule in our programs. Whether you realize it or not, the implicit binding rule is used all over the place. So that's 3 of the 4 rules, and that's pretty simple. And finally, the fourth and final rule to look at, if none of those other rules apply, this 4.js is the default binding rule. We have a plain, old, normal, undecorated, simple, naked function call. There's nothing to it. Just a regular function call. None of the other rules apply. The 3 rules that you asked in that order do not apply. So the fourth and final rule says, in non-strict mode, the this keyword is going to point at the window object, the global object. And in strict mode, it's going to be undefined. By the way, you should always be using strict mode. If you're not, you're way late to the game. Start using strict mode. Period, end of story. All code should be strict. So in this case, if you had strict mode turned on, you would get early errors because you'd be trying to access a property off of something. Instead of getting it accidentally off the global object, you'd be getting the this off of an undefined, which would be throwing you errors. So you definitely want to avoid non-strict mode and the default rule. That whole thing where it can be the global object is a terrible idea. 4 simple rules. Does the new keyword appear in front of it? Does call or apply appear in front of it? Does an obj1 appear at the call site? You know, a context object appear at the call site? And finally, the default rule, strict mode undefined, non-strict mode global object. That's it. There's literally no other complexity. I've taken all the complexity of the spec and boiled it down to that simple 4 rules. You too can also be a master of the this keyword. One last statement that I'll make on the this keyword, and then we'll move on to our last topic, is that JavaScript ES6 is adding a new mechanism called the arrow function. And this arrow function is totally being misrepresented by most of the people that are talking about it because they're saying, well, it's all about not having to write the function keyword. It's actually about being able to use this mechanism called lexical this, and I'm not sure whether that's a good idea, but I love this idea. I love this tweet from Angus Kroll. He's a brilliant guy, and he said, there's actually a lot of beauty to the dynamic binding of this, and people never understood it, so they created a whole new mechanism so that they didn't have to understand it, which is kind of ridiculous. How many of you have ever done var self equals this in your code? Anybody? Anytime I see somebody doing var self equals this, it's almost certainly a statement that that person doesn't understand how the this mechanism actually works. Because that's mixing the two. It's taking the this mechanism, which you have to go to extra work to use, and doing it the wrong way and falling back. And when you can't figure it out, then you fall back to lexical rules, which we're all more naturally inclined to. You shouldn't be mixing that. You should never do var self equals this. That's ridiculous coding. And the same thing is true of the arrow function. If you need lexical this binding, you're doing it wrong. You don't need the arrow function for that, and you don't need var self equals this. Pick one of the 2 styles for any given unit of code. For each logical unit, pick one or the other. When you mix the 2, you get Frankenstein code, and it's just ridiculous. So, our last final topic that we'll jump into is object orienting. Everybody loves object orienting. I love this t-shirt. I wish I'd gotten a chance to buy it while it was still available because, in fact, as I said earlier, JavaScript is classless. There is no such thing as classes in JavaScript. You've been taught that there is. You've seen people create libraries to try to fake it. I'm going to very quickly derive for you why I think that's total nonsense. There isn't any such thing as classes, and even when they are adding even though they're adding a class keyword, there's still not going to be classes in JavaScript. So, the first thing is that all this confusing terminology, class and inheritance and constructor and instance and all that, that's all junk that comes to us from other object-oriented languages, class-oriented languages. None of that stuff exists in JavaScript. It's nonsensical, it's misdirection. We've wanted to do that because we didn't ever think about looking at the way the mechanism really works. My favorite, worst part of this is when people put the word prototypal in front of the word inheritance. which is ridiculous. JavaScript does have a mechanism called prototype, but it has absolutely nothing to do with classes. So let's look at this whole idea, lint, man, prototypal. Let's look at this whole idea of putting the word prototypal in front of inheritance. I don't have a lot of time to get into this, but the word inheritance implies copy mechanisms. Both genetically speaking, you copy your DNA, metaphorically, the blueprint in the house that's being built. On all those ways, inheritance is about copying of behaviors, and JavaScript by default doesn't do any copying. So it's not appropriate to use the word inheritance to describe JavaScript's mechanism. But people like to put the word prototypal in front of it and say, no, 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 this is our special form of inheritance in JavaScript. We just call it prototypal inheritance, as if that's somehow supposed to make it not confusing, which actually just makes it worse. I liken putting prototypal in front of inheritance and pretending that it reverses to like me holding an apple in one hand and an orange in the other, and then suggesting to you, no, 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 that's not an apple, it's just a red orange. It's absolutely ludicrous. You'd look at me like I was crazy. It doesn't matter what word I put in front of it. It doesn't change the intrinsic nature that that thing is an apple. So you can't put prototypal in front of it and then get to pretend that that doesn't mislead people into thinking something that's not actually true. So what's really wrong is we've been, from the very beginning, we've been using the wrong terms for these things. So I want to set up a comparison between the more common term that everybody knows, OO, object-oriented. Really, object-oriented means class-oriented. OO versus another term that I've come up with called OLU. Objects linked to other objects. In fact, this is really a comparison between class-oriented and between what I think JavaScript should have been called all along, which is behavior delegation. Okay? And I want to show you a couple of pieces of code to illustrate this difference, or what I call OLU style coding. So we start out with the traditional way that people do things that they call classes in JavaScript. Diagrammatically, classes in traditional class-oriented languages start with these copies. The arrows go from left to right and from top to bottom because the properties are copied into instances and into child classes. So we see in JavaScript that when people try to do that, it doesn't work at all the same way, which is why everybody uses these crazy frameworks on top of it. So let's look at class.js. This is how people do, or how is suggested sort of natively to do class-oriented coding in JavaScript. All this nonsense with function constructors and .prototype and the new keyword and all this other junk, this is just crazy confusing code. There's an untold amount of gotchas that are here, which is why nobody actually writes code like this. Because it's so difficult to do class-oriented coding in JavaScript. We're swimming so far against the stream, everybody uses these crazy big complex libraries to do class-oriented coding for them, which is, I think, ridiculous. If you can't use a mechanism the way it was designed to be used, then you're doing it wrong. You don't need another library, you just need to figure out how to use the mechanism better. So this whole prototype thing and this new keywording thing, this is all nonsense. I don't think we should be doing it. And you'll notice here the linter just has all kinds of warnings. I'm not even going to belabor the point. There's all kinds of warnings about being careful about these things and just arbitrary .prototype references that are writable and that can create confusion. Here's the real problem. There's too much complexity to the mental model to be able to actually juggle all of those problems. Here's one diagram that I'll give you. Let me give you a simple version of it. Here's one diagram. It's a little hard to read here, but these squares are objects and the circles are functions. And you notice these relationships. These are the prototype linkages. This is the diagram that exists from that previous code, and actually, this is the real diagram with all the extra stuff involved. And there's two takeaways, both an optimistic and a pessimistic takeaway. Optimistically, the takeaway here is that there's a lot of internal consistency in JavaScript, but pessimistically, this stuff is just too damn difficult. Nobody can keep this stuff in their head. I've been doing it a long time, and I can't keep it in my head. So that's the problem, is that it's just not possible. But if we embrace instead how JavaScript actually works, if we look at it as delegation, using that terminology, you'll notice the arrows now go from right to left and bottom to top. Because in this particular scenario, now the relationship is how it actually works in JavaScript. These are live linkages on the prototype chain rather than copies of properties down the chain. And that's what JavaScript actually does. So I'm going to give you, very quickly to finish things up, I'm going to give you what I call OLU style coding. Does exactly the same thing as the previous confusing snippet of code, but now it uses and embraces this idea, oops, didn't open up my file. It embraces this idea of OLU. So you notice I still have capital F foo and capital B bar, but they're not functions anymore. They're just objects. And now I'm putting properties directly on the objects. You'll notice this code snippet is completely devoid of any .prototype references or constructors. There's no new keyword. There's none of that confusing crap. The only thing that actually, the magic that makes it happen is this object.create utility, which is added natively into the language. It's a very simple polyfill for it. And object.create just simply creates objects and links them, and doesn't go through all the fanfare of trying to pretend to be class-oriented to do that. I've got a lot of writing about this. It's too quick for you to understand all of the code, but it's actually very straightforward. In the second of these books, this and Object Prototypes, it goes through all of this topic and explains exactly how OLU works and why it creates simpler code. And in fact, not only simpler code, but here's the big payoff. It creates simpler mental models as well. Oops, what did I do wrong? Here's the new model. It's just objects linked to other objects. We don't need any of that other confusing crap. So, I apologize if I've offended anyone, because there are a whole bunch of opinions here, and, you know, opinions are just to be taken. These are just opinions, and you can ignore the linter if you want, so hopefully there's no hurt feelings. We are on a break here, so I will not take questions in our session, but if you want to come up and ask questions of me you know, during our break, that's great. But I just want to remind you that you can reach out and give feedback on Twitter. Also, please definitely make sure to vote on the app so that we get good feedback. And reach out to me in all the various ways and tell me if I'm wrong or something. Don't forget, first 3 people that want to grab a copy of the book's free. There's free stickers. And have a great rest of the conference day. Thank you.